Hello everyone, welcome to Scalers YouTube channel. My name is Aditya. I'm currently working as a data architect at PepsiCo. In Module 3, we are going to talk about the use cases around batch versus streaming pipeline. Then we are going to deep dive into Azure Cloud and talk about its components.
Hi all, welcome to Module 3 of Data Engineering. In my previous session, Module 2, we were talking about ETL and ELT. We left while we were discussing about ETL process. Let me open the diagram again and let me explain it again. So ETL stands for extraction, transformation and loading. The extraction happens at the source side, right? And the transformation happens on staging area or staging tables. Staging area is nothing but an area where you store the data in its raw format, you apply the transformations and you store it in stage tables, right? So my stage table consists of transformed data. So when you ask about transformation, it can be some basic to medium to complex transformations. For example, I want to append zeros in front of zip code. So for example, my zip code is 50072. So if I want to append 00 in front of zip code, I can apply some transformation. So I will extract the data in its raw format. I will load it in the staging area. In the staging table, I'll apply the transformation as per the business requirement. And finally, I will load the data in the target. This process of ETL is achieved through a pipeline, which we have showcased over here, right? This is nothing but a pipeline. Okay, I'm denoting it by P. So the pipeline is used to connect to source and to target and to staging area. So from source it goes to staging and staging to target. But I'm just showing you the arrow mark, basically the direction from which the data flows, right? The process is called as ETL, right? And now someone asked me what is ELT? It is a simple thing. Again, the boxes remain same. Here is our source, here is our target, and in middle somewhere we will be having our staging. So you can assume that this is our stage area. Source, this is my stage, or you can consider this as intermediate layer. This is my final layer called target, right? So in ELT process, okay, this process which I'm explaining right now is ELT. So I will extract the source data first, extraction. I will load the table in an intermediate layer, okay, loading, and finally we will transform the data before loading it into target. So here in this case, I'm extracting the data, I'm extracting all the data, I'm transforming all the data, and then finally I'm loading it. But in this case, I first load all the data in my intermediate layer. Now, depending upon the business requirement, I need not transform the entire data, right? Though I have pulled all the data here, extracted and loaded it. In this case also, we have extracted all the data and loaded here, but we are transforming all the data. Basically, before loading, we are doing transformation and we are performing transformation in all the data. But here in this case, we extracted all the data because extraction is an easy process and storage costs are very minimal. So I have extracted all the data, I load it in an intermediate layer, and based upon the business use case, I will transform some amount of data which is required by the target. I need not transform the entire data. Transformation is a very costly process, right? It takes compute. So I can pull all the data and now depending upon the business requirement, I can transform it. Based upon the business use case, I can transform it and I can load it in the target. So this process is called extraction, loading and transform. This process is known as ELT process. Now if you ask me, companies have both the process ETL and ELT. Initially companies used to load the data, transform all the data and finally bring the transform data on the target layer. But nowadays, most of the companies they depend upon the ELT process. Why? You can load all the data on a central repository, okay, load all the data in its raw format, but transform only those data which is required by the business. For example, I have loaded 32 states data of India, right? But I only want to visualize or perform some analysis on Mumbai, for example. So I need not perform analysis on all the 32 states. I need not perform transformation on all the 32 states. In fact, I can bring all the 32 states data over here, perform transformation only on Mumbai. But why did I bring all the data here? Because today we are doing analysis on Mumbai, tomorrow it can be some other location or any other state, right? So instead of performing all the analysis or transformation of all the data, I will just perform on Mumbai or on the sample data, right? This process is much more flexible because it tries to save the time. Instead of performing the analysis or transformation on all the data, I'll perform it as per the business requirement. So this process saves a lot of compute, a lot of infrastructures and money for the company. That's why ELT process is very much used widely in the market. So I hope you have understood the difference between ETL and ELT, extraction, transformation, loading, extraction, loading and transformation. The ideal use case scenario is, for example, I'll take the same example of a credit card. You swipe a credit card. Let's say you have used a credit card to withdraw some amount in an ATM, right? The ATM has sent out some data like debited amount from the account. It goes to some staging area where some transformation is performed. Let's say some integer number has been converted to decimal, right? The transformed data is then thrown to target. Here in this case, we have transformed all the data because it's money. And but in ideal scenario, we only transform the data which is for that particular use case or for a particular locality. Let's say this ATM is in one particular location. I only want to study the data of that particular ATM. So I'll fetch the data of all the ATM, but I will only transform the data of that particular ATM which is nearby my locality where I have done the transaction. So that example I can give you for both ELT and ETL. So I have explained the difference between ETL and ELT and which one to use. So these days companies rely on ELT process as they can only transform the data which is required as per business use case. This saves money in terms of compute, resources, time, etc. Right? So this was what I wanted to explain about ETL and ELT process. Both are one and the same, but depends upon how we go forward. How we take the process of loading the data in the target, right? So in ETL we transform all the data, but in ELT we load all the data, transform only certain part of the data, and then load it in the target environment, right? Let me go to the next topic, which is different terminologies: OLTP, OLAP, and data marts. So what is OLTP? This is very much important. I want to build a strong basement for you guys. It is called as online transformation process, sorry, online transactional process. Online transactional process system. OLAP stands for online analytical processing system. So, based on the definition, OL means online transactional processing system. What is transactional process system? This system captures live data and they are used for capturing the recent transactions. They cannot maintain huge amount of history data, right? Example, we can take an example: database, any database. OLTP stands for online transactional processing system. This system can only capture the transactional data which happens on second to seconds, minute to minutes or hourly basis, right? Why they are useful is because the transactional data database cannot hold all the history data or all the past data. Why it cannot hold? Because of the size constraint. This OLTP system is not useful for storing history data because we are not doing any analysis on it. We are only capturing the transactional data to understand where or when a particular transaction has been made, who has done this transaction, and at what timestamp this transaction has been made, right? To understand who did the transaction, when it was done, where it was done, to whom it was done. All these details are stored in an OLTP process. For example, swiping your debit card in supermarket. So once you swipe your debit card, okay, it will store information such as the card has been used to perform a transaction where at supermarket by using your debit card. It was done by you because you are using your debit card, right? And the timestamp exactly when the transaction was done, to whom it was done, basically towards the supermarket, and what was the amount. Amount is also there, so I'll write amount here, right? So all the transactional data, basically all the live data or hourly based data is captured in an OLTP system. Now you will ask me, hey Aditya, then why we are using OLTP system? So basically, all the data from different OLTP system flows to OLAP, which is online analytical processing system. Analytical itself means it is used for performing some analysis. So example is data warehouse. So what is a data warehouse? I'll explain both database and data warehouse in depth because when someone is working on data engineering, they need to understand and connect, okay, why data warehouse is used. Okay, so different OLTP system, basically different database data is captured in one data warehouse, is captured in one online and analytical processing system. Why it is captured is because we need to store the recent data till the history data of all the transactions. You cannot store all the history data in your OLTP system. Once certain timeline is crossed, let's say 1 month or let's say bi-weekly data is crossed, all the bi-weekly data is moved to this data warehouse. So you flush it and you fill it in your data warehouse. So all the history data is maintained in a data warehouse. Again, it depends upon the company to company how much history they need to maintain. But yeah, the history data for all the different OLTP system is maintained in a data warehouse. Modern data warehouse are Teradata, then we have Synapse, right? You can use different data warehouse depending upon the requirement. Data warehouse will be helping the Power BI reporters or Tableau reporters, basically any BI engineer, to give you the history data. By studying the history data, people can create a kind of visualization to see how the company was performing before, where the company is performing now, where are the profits or where it is seeing losses, all those things, right? So that's why my OLAP system is basically used to store history to till date data, year to date data, basically from history to year to date, and it is basically required for performing the analysis, right? That is the meaning of OLAP. I hope OLTP and OLAP make sense now. In a pictorial format, I can showcase like this is my OLTP system. There are different OLTP systems, let's say OLTP. This is also one OLTP system, online transactional processing system. OLTP is nothing but a database, right? And you have a data warehouse, right? You can connect different databases in a data warehouse. This is nothing but a data warehouse, which is an OLAP system. These are my DBs, database 1, and this is my database 2, right? I'm moving the data from database 1, database 2 to my data warehouse. This data warehouse will store all the history data from, let's say, 16th of January till last 6 months of data. Now, once the company realizes, okay, the 6 months of data has crossed, I'll flush all the 6 months data from this data warehouse and move it to some other data warehouse. So, data warehouse is used for analytical purposes to, you know, produce Power BI reports or any visualization reports. We also have something called as data marts, right? Data marts are kind of a data warehouse. Data mart 1. This is data mart 2. So data mart, what is data mart? Data mart is a kind of a data warehouse which is used to store the functional area related data. For example, HR, if I want to perform some analysis on HR data, but data warehouse will have all the functional data, right, belonging to HR, IT, operations, sales, etc., etc. But if I suppose if I want to build a chart or a report only on HR data, then I can fetch all the history data of HR over here in data mart 1, all the sales related data for all the sales representative in data mart 2. Because I only want to perform analysis on HR and sales. I don't want to perform analysis on IT. So I can build different data marts which are similar to data warehouse. It's a small scale data warehouse with respect to a particular functional area, right? These are called as data marts. And finally, the Power BI reports. These are the reports which are built by using these data marts, right? Different reports you can build. These are called as Power BI reports. Cool? Understood? So this way, all these things are interrelated. So database can only store month level data. More than that monthly, we cannot store data because it again depends how much scaled up the database it is. Uh, but yeah, if the database size is very huge, again, performance wise, it will give us some trouble. So we don't maintain a huge history of data. We usually we transfer all the data which is in history to a data warehouse. So this is a diagram which I wanted to discuss so that people who are studying data engineering in depth knows about all these tools or technologies or components before we go ahead. So I have talked about difference between OLTP and OLAP system and what is basically data mart. Now let's understand the very much important concept on-premise and called cloud. We've been discussing about different things, OLTP, OLAP. Now I also want to discuss about difference between on-premise and cloud. So people might think, okay, why I'm talking about all these, new terms and terminologies? It's because once we deep dive into the concepts, that time you will be aware, okay, this topic was discussed earlier, and that is the reason Aditya is discussing about it now, right? On-premise, and this is cloud. Draw this diagram so that you guys will remember every time when you sit for the interview. Okay, similar diagram over here. So I will explain this concept in a very layman language. On-premise is like own house. Cloud is like rented house. Okay, point number one is clear. I'll explain again in depth. We need to maintain and perform all the activities by ourselves. We need not perform all the activities by ourselves. It depends upon the amount of responsibility shared. I'm just writing the points initially and I will discuss again in depth about each and every point. Okay, flexibility is less, high flexibility, more security, I can say more privacy because it's my own house, less privacy because I can expect my landlord to come anytime at any point of, at any hour, so privacy will be less. More security because I'm the only person living here. There is no, neighbors in this house. But yeah, in a flat, in a rented house, top floor might be given to someone, bottom floor can be given to someone. So security wise, it will be a little bit less, right? Little bit less. What is on-premise? On-premise is like owning a system by yourself. Okay, you have to update it. You have to, uh, you know, ensure the proper functioning of it. You have to provide all the patches for it. You are the sole responsibility of that system. It's like my own house. In my own house, I need to take care of my own house. Basically, I need to clean it. I need to maintain the neatness of it. I need to paint it. I need to do the washing and everything. I need to take care of everything. So own house means the entire responsibility is on me. But when I talk about cloud, cloud is a system or a machine or an enterprise given by a third party company. Let's say Amazon, Google, or Microsoft, right? So when they give us a service, so cloud is a kind of a service. You can host your data on a machine which is provided by cloud. You ask them any service like storage or processing, they give you those services, but they charge for it. As you go or offer them, the charges might increase, right? So cloud is like a rented house, depending upon what I want. They're going to give me that service and they're going to charge for it. For example, if I take 1 BHK flat, the rent will be for 1 BHK flat. If I take a 2 BHK flat, the rent will be for the 2 BHK flat. So depending upon what I want, the rate I have to pay from my own pocket. So it's like a rented house. And here the responsibility will be very less depending upon how much shared responsibility is given to me. So the landlord can ask me, okay, you can stay here. I will give you all the services like electricity, water, and everything, but you need to pay the water bill and the electricity bill. So some kind of responsibility is given to you, but yeah, the maintenance of the house, painting, pest control, everything else will be done by the landlord. You need not worry about it. But yeah, the some aspects of it you have to take care. Like for example, paying the electricity bill, paying the water bill on time. That is something which you need to take care. So in own house or in on-premise, you need to take care of everything. But in cloud, some responsibilities are given to the third-party company like Azure, Amazon, Google. So they have their own cloud. Google has GCP, Amazon has AWS cloud, and Azure is from Microsoft, right? On-premise flexibility is less. I have to stay there. I need to make sure I am there because I'm taking care of everything. If I go somewhere, something might happen on my behind or on my back. So I, flexibility wise, it is less. Cloud, since it's a rented house, I can lock it and I can go anytime because obviously there are some other people who are staying there or there are neighbors, right? So security wise, flexibility wise, flexibility is high, obviously in a rented house. Own house means I cannot directly sell away that house very easily. Rent means I can just pack my bag, clear the rent, whatever I had to pay, and I can go to other house. But if I have my own house, I cannot leave my own house and go to other house easily, right? Whereas if I'm on a rented house, if I don't like something, easily I can go from one cloud to other cloud, right? So flexibility wise, flexibility is more in a rented house, which is nothing but cloud. Now let's say privacy. Consider you have a duplex home, duplex house. Ground floor is given to other family. Topmost floor is given to some other family. Privacy files, do you think that there will be privacy? I don't think there will be privacy, right? There will be sounds or noise or some other kind of disturbance. Same thing which happens in a PG. In your own house, which is on premise, security and privacy will be high because no one else will be intervening with your activities. Whereas in cloud, Since you're staying with some other people whom you don't know, whom you don't have trust upon, privacy issue will be there, security issue will be there. So that's where cloud gives you different kind of services again. Within cloud, you have different types of cloud. Public cloud, you have hybrid cloud, and then you have private cloud. If obviously, if some government company wants to host their private data on a cloud, which again is accessible by that government agency only, that should be stored in private cloud. You cannot use hybrid or public cloud. Private cloud is very costly because the third party company will take care of all the privacy and all the security of the cloud. They could have used the on-premise, but yeah, they cannot perform all the activities by themselves. They cannot give all the activities to other companies, right? Because it is on-premise, it's our own house. So I need to spend additional resource to work upon them. Instead, I'll only spend those resources to work on them only when there are some work required, right? Otherwise, I need not pay for it. So that's the difference between on-premise and cloud. On-premise is like my own house, cloud is like the rented house. So I hope you will remember this difference whenever you sit for the interview, right? Let me go to the next topic, which is so we discussed about ETL, ELT, the different terminologies like OLTP, OLAP, and data marts. Just now we have discussed about on-premise and cloud. Now let's talk about batch data and streaming data. Before I talk about, we also discussed about cloud. Cloud is nothing but third-party companies which are offering their services to different clients or companies which they can use based upon their requirement. So what cloud? Cloud is it? It's like a machine which you cannot see in cloud basically, which you cannot see as a. I mean, these are virtual machine. These are huge, huge, big data centers. Sometimes they are, they're so big like they dip those data centers into the ocean, right? These data centers are storing huge amount of data, and each data center is maintained across different locations across the earth or the geographical locations. So clouds are big machines which are owned by these big companies, which provides different services like storage, compute, depending upon what type of compute you want to do. They give different kinds of services, and now it depends upon the companies which service they need to take. Obviously, just using the service for a particular duration of time, I just need to pay for that time. Instead of maintaining the entire infrastructure at my own company, I can only use those services. For example, if you don't have laptop, right? Or if you have a laptop but you don't have a program to run on your laptop. So what you can do, you can go to cloud, buy the resource to do compute, and perform all the necessary calculations or analysis required on the cloud. Pay for those particular duration of time, perform or complete your project, and then once project is completed, close the account because your work is done. Instead of buying a new laptop, you could have rented the cloud for a few weeks to complete your project, right? This is nothing but cloud, right? I have answered question number 10. Let's go to question number 8, difference between batch data and streaming data. Difference between batch data and streaming data. So what is batch data? So data warehouse. So data warehouse stores history data, right? When you move, when you want to move the history data of a company, let's say last 2 years, 3 years, 4 years, you cannot bring all the data at once, right? Because these are huge, huge volumes of data. To bring that data, we need to bring that data in batches, right? So let's say you have last 3 years of data. I can bring 1.5 years of data at once, or I can bring 1 year of data at once. So I'll bring 2021, 2022, 2023. I'll bring it in this fashion, right? In different batches. So either you can do this, right? Or you can go a bit more granular. I can bring 6 months data in one batch, right? So similarly, I'll build a different pipeline to get or fetch 6 months of data every now and then, right? So batch data is used to pull or bring or fetch data, which is mostly history data, right? Because the volume of data is so high, you cannot bring all the data at once at a time, right? You need to bring them in batches. That's where batch data processing is used in big data. So wherever you need to bring history data for some analysis, then you need to bring that data in some kind of batches. Why? As the volume of data is high, you cannot bring all the data in one shot, right? Since the data volume is so high, you cannot bring all the 3 years of data in one pipeline or in one shot because the GBs of the data will be so high. You might be, you know, create a pipeline which might fail or whose performance will be very slow, or you might try to corrupt the data which is present in the source. So that's why batch data comes into picture where I'll be building pipelines. I'll build pipelines in such a fashion that it will bring the data in samples, like 6 months of data or 1 year of data, and it will load in the target area. So the next pipeline will bring me the last 2 years of data. So first pipeline ran the last 2 years back of data. I mean the third year's data from the last. Next pipeline will bring me last to last year's data, and the last pipeline will bring the last year's data. Right? This is called as batch processing to bring the history data. Now what is streamline? So example I can take to study my performance in school in last 2 years of schooling. If I want to see how I have performed in class 9 and class 10, I need to bring last 2 years of data. Obviously, I'll bring the data in batches. This will tell me, okay, I have performed in this way 9 and 10, and then based upon that, which study or which subject I need to choose, right? This is called as batch data. Now, what is streamline data? To fetch the real-time data or near to real-time data, we need to bring the data and process it so quickly so that we can give uh, advice or recommendation accordingly. Here I can take one more example. Example, Amazon. It will study. It will study the history of your purchase, and it will give you recommendations based on that, right? So what is streamlining data? So in order to fetch the real-time data or near to real-time data, we need to bring the data and process it so fast so that I can take some decision or I can give some recommendation accordingly. For example, FIFA World Cup was going on. I have fetched the data and understood, okay, these many users are watching the channel. Now, if I want to increase the storage capacity or, if I want to increase the number of machines so that users can still log into the OTT platform to watch that particular channel, I need to study the real-time data, basically how many users are entering into the application. So I want to study that. So this fast data which is flowing, basically in every second or in every minute, some users will be logging into the app. If all the users logging are logging at the same time, then the app might crash, right? For example, same Amazon. So they want to study the real-time data, like how many users are entering into the app, how many are trying to purchase. So I want to increase the number of machines in the backend so that my app or my functionality of the app will not crash, right? So to streamline or to fetch this latest data or live data or near to real-time data, I need to have a pipeline to fetch the real data or near to real-time data. This pipeline is called as streaming data. The pipeline which fetches this live data is called as streaming pipeline. It is not streamlining, it is streaming. By mistake, I've written streamlining, it is streaming data. So batch data is used to bring history data. Streaming data is used to bring live data or near to real data. Another example is I can give you is, for example, let's say there is a disaster and I need to give an alarm to all the people living in a particular area. For example, Japan. Japan, there will be a lot of earthquakes or volcano activities. So in case of such disaster, I need to alarm the public in a very quick fashion. So basically, there are some sensors or IoT devices near the earth, basically near those epicenters where usually those activities happen. I need to capture the data, process it, and understand, okay, whether this is a data, real to near time data of a live earthquake. If yes, I need to capture the data quickly, process it, and trigger the alarm so that people will understand, okay, we are going to see an earthquake, so that they can take proper measures depending upon that data. So to fetch this fast data, to process it, we need streaming pipelines. This is the difference between a batch data and a streaming data. Streaming is for fast moving data. Batch data is for data which can be moved slow, right? Hope you have understood the example. You can take example for controlling traffic. Suppose traffic is very high in one particular area, let's say Koramangala of Bangalore is seeing a lot of traffic. So I'll fetch the real-time data like how many vehicles are standard. Okay, I'll try to see okay which road near to this road is empty. I'll try to regulate the traffic by diver diverging the the traffic in that area. Basically, I'll stop the vehicles incoming and I'll move or divert them to some other area. That is also an example of streaming data, right? I have think I have covered this answer. Now let's move to this difference. It is very important. We'll cover this in the explanation now. Okay. SaaS, software as a service. We have PAAS, platform as a service. We have IAAS, which is infrastructure. Infra. So, what does each definition mean, right? These are all concepts of cloud. I wanted to cover it because down the line when someone is talking about all these terms, people know okay what we're talking about, right? SaaS. SaaS means software as a service. Example, Microsoft Suite. Whenever a person is purchasing Microsoft Suite, they will get Microsoft Outlook as one of the softwares, right? It is an inbuilt Outlook software. It is an application or a software I can say inbuilt which everyone uses to send emails or to receive emails, right? It's a part of Microsoft Suite, obviously. Similarly, Microsoft Excel, it's a software which people usually use. It is again a part of Microsoft Suite. All these companies like Microsoft, Amazon, Google, they have a lot of softwares which they offer as a service. Basically, they'll give you all these applications or software which you can buy obviously on a yearly basis. So you will receive a key by using which you can access these tools, right? Or these softwares or applications. So any company which is offering the software or application as a service for which you need to pay or on a yearly basis. So those tools or technologies or applications what you use are called as softwares, and it is given as a service by these companies, right? So I hope you have understood it. Example I can write Microsoft Outlook or LinkedIn. LinkedIn Premium is a software as a service. LinkedIn free version, you don't see that many things, those many prospects of it, but yeah, Microsoft tool, LinkedIn Premium is basically software as a service example. Platform as a service. I can give you the best example is Azure Cloud. Azure Cloud. Okay. So what is platform as a service? Azure is a huge cloud. Basically, it gives you a platform of different services. Now, if someone wants to use Azure Cloud for storage purpose, they can use a particular feature within it, right? Azure Cloud is a huge platform. Within it, we have different services. Let's say for storage, you have ADLS service, right? For creating a pipeline, you have Azure Data Factory. For transforming your data or for performing some read activity on data or making some high transformations, you can use Azure Databricks. For streaming analytics, you have Azure Stream Functions. You have Power BI within Azure. You have Azure Data Fabric. So there are a lot of things within Azure Cloud, which is a platform where you can utilize any service based upon your need or requirement, right? Platform is basically it's a combination of different services. Azure Cloud is a combination of different services under one single platform, right? So software as a service will be one particular service within a platform, but PAAS stands for platform as a service, SaaS stands for software as a service. Within a platform, there will be multiple softwares as a service, right? Example I have already given, like Azure Databricks, Azure Data Factory. These are all different softwares as a service. Depending upon the usage, how much data you are using, you have to pay for that. But you can buy all these different applications under one umbrella, which is called platform as a service. IaaS, infrastructure as a service. Example, all the data centers. Example, best example I can give you is the data centers. I can write here. So the data centers is basically those big machines which stores all huge amount of data. So Azure has its own data center located in different geographical locations. They can give you the entire infrastructure as a service. Basically, they can give you one host server, resource group. Basically, they can give you a management group. Within management group, there are different subscriptions. Within subscriptions, you have resource group. Within resource group, you have multiple resources. So basically, they're giving you a very big data center called as an infrastructure. You can utilize your infrastructure which is given by Azure for your own use case. You need to think how you need to use this infrastructure for your own specific purpose. Within infra, they'll give you all the required things like firewall, architecture, how the data has to be stored, you know uh, those things they'll give you in that kind of advice, but how you need to use the data, where you need to store the data, what all different applications you need within this infrastructure, all this decision comes to you only. It is not maintained by the company. They'll just give you the infrastructure. Okay, this is the architecture, this is the infrastructure. Now it is up to you how do you use it. So if I think okay, there's too much of responsibility, I can directly go for a platform. But if I have to maintain the entire infrastructure of my company on a third party infrastructure, I can directly buy their infrastructure and then design according to my needs, right? These are the different terminologies which we usually see in Azure Cloud, which is SaaS, software as a service, IaaS, infrastructure as a service, and PaaS, platform as a service. So I think I have covered almost all the topics of my module 2. Some of the topics which were left out were covered in module 3. We'll go to the next topic, which is data locality, and we'll start discussing our topics upon Azure Data Factory, okay, why it is used, and components of Azure Data Factory. So before I talk about Azure Data Factory, let's talk about data locality. Basically, it talks about where the data is stored and where it is processed. Usually, in big data world, we process the data where it is stored. So we don't move the data towards the compute. We move the compute towards the data, right? So what does data locality mean? Data locality means I want to understand where my data is being stored and where it is being processed, right? So if suppose I have very huge amount of data, I cannot move all this data to a particular compute. Initially, yes, this was the way it used to process, right? For example, in my computer, I have hard disk. All my hard disk data will be fed to CPU for processing. But these days, big data amount of data is so high, I don't want to move the data towards my compute. Instead, I'll move my compute towards the data where exactly the data is residing. I need not move in the other way around. Basically, I will not move the huge chunk of data towards the compute. So data locality talks about a concept where I'm storing the data and where I'm processing it. So I will store the data in any location, but I'll move the compute towards that location so that the processing will happen exactly in the same place where the data is stored. So it's a very important concept in big data engineering. I hope you will remember it. So data locality usually means storing the data and processing it wherever it is stored. So let me see if we have additional time so that we can start about Azure Data Factory. I think yes, we still have time. What is Azure Data Factory? We'll try to cover here. So Azure Data Factory is an ETL tool or data cloud data integration tool. It is used to fetch the data by building pipelines, comma, by connecting various sources to targets, by performing simple operations or transformations. Okay, we can also orchestrate our pipelines in Azure Data Factory, right? So what is Azure Data Factory? Azure Data Factory is an ETL tool or a cloud data integration tool. When I talk about cloud data integration, it means I want to integrate different source data, right? Integrate as in I want to aggregate or integrate or combine all these different data setting across different places. How do I fetch this data from which is setting in different places? I try to bring a pipeline. I will build a pipeline which connects the different sources to a single target area, right? That's where I am going to integrate all these different data which is sitting in silos. So Azure Data Factory is a tool which is used to pull the data from different sources to a particular target. How do we do it? We build pipelines which connects different source connectors. So we have around 99 source connectors, right? We also have around 99 plus target connectors. So we connect to different source and target by using different connectors. We call them as link services. We'll talk about them. And by using these different connections, we try to pull the data from source and then we load it into target. This is the main tool usually used in Azure environment to pull the data. And there's not much coding involved. It's a low to no code tool basically. There are functions involved obviously, but yeah, ADF is basically done on a UI. Like, it's very easy. If you learn this properly, the chances of you landing a job in Azure data environment is very high, right? So I hope you have understood what is Azure Data Factory. Azure Data Factory is an ETL tool which is used to fetch data from source to target, right? Now I'll discuss about the components of Azure Data Factory, different components in Azure Data Factory. We'll talk about many. I'll be talking about the main points or the main components in Azure Data Factory. Tomorrow in Module 4, we'll be discussing about different components, different concepts under Azure Data Factory, and then we'll try to build one project also in depth. So different components are link service, dataset, integration runtime, pipeline, activity. So what is link service? Link service is a kind of a connector. Okay, it helps us to connect the pipeline to a source. Similarly, it will help us to connect the pipeline to a target. For example, let me take a diagram. This is my source, this is my target. Okay, I am building a pipeline to fetch the data from source to target. This is the pipeline, right? Now, this is a link service. Basically, it's a form which you will fill to derive a connection between the source and the pipeline. So, for example, once you let me take an example of an Amazon delivery guy. Okay, delivery guy asks, works on a link service. Delivery guy will pick up the order from warehouse, come to your home. This is your home. This is the, let's say this line is the warehouse, or let's say this is a warehouse. This line is your home. Delivery guy will come here and he will try to authenticate whether it is you who have purchased. So you will share OTP on your phone to the delivery guy, say that okay, this is the item which I placed as an order, this is the OTP, please deliver it to me. So basically you are communicating with the delivery guy so that you can connect with the warehouse order which you have received. So in the same way, in order to connect my pipeline with source, I need to fill out a form which I call as a link service. I will give I'll give the information such as host server name, some connectivities, all these things I need to fill out in a form. Integration runtime, whether it is a auto resolved integration runtime or it's an SHIR, right? The password, user ID, all these things I fill it out on a form, which is used to authenticate the connection between the source and the pipeline. Similarly, I'll use another link service here to connect my pipeline with the target. So for different sources, we have different types of link services, right? For now, I think we have 99 types of different link services, but yeah, the numbers might have increased. There are, I think, 100 plus now connectors which can help you to connect with different source. So let's assume this is one source. If we have another source over here, the link service might change. You cannot use the same link service to connect this source with this target. You might have some other link service, right? So link service is used to help us generate connection between the pipeline and the source or between the pipeline or target. It is used to authenticate the connection. Now what is dataset? Dataset will tell you the type of data or the structure of the data which you want to extract. For example, if you are fetching a CSV data, the data type will be CSV. If you are fetching an Excel data, the data type will be Excel. If you are fetching JSON data, the data type will be JSON. So when you're creating a link service only, basically if I want to pull out my source is basically a CSV file, right? In my link service which I create, there I have an option to define the data set. There I will see CSV as a data set. I'll show you when we're talking about how to create a pipeline. We will discuss that in depth. Similarly, if I have an Excel as a source, I have Excel file as a source. I need to bring this CSV file to target. I need to bring this Excel file to target. So to connect my pipeline to CSV, I'll fill out a link service, which is a form. I will talk about what all details you need to fill in this form. But at the data set, I will select the structure of the data which I want to pull in the format of a CSV. Similarly, I'll select the structure of data in the format of an Excel, which is called as a data set. So depending upon the different type of file you're loading, if it's a JSON file or it's a XML file, you can select different data sets. Again, there are 99 plus data sets. The number might increase, but again, yeah, these data sets are part of link services. And it tells us about the kind of data or the structure of data which you want to pull. Integration runtime, basically, they are powerhouses or fuel for our pipeline. They provide resources for compute. Basically, they're powerhouses for a pipeline. Basically, it provides the energy for the pipeline to go and pull the data from a source and then load it into target. So there are different kinds of integration runtime. We will talk about it in the further classes, but I want to give you a generic overview. What is integration runtime? Pipeline is basically this diagram which I have shown. Pipeline is a component which is used to pull data from a source and load the data in the target. Finally, activities. There are different activities which will be, talking about while building a pipeline. So for example, to pull the data from a source to target, I have one activity which is called as copy activity, right? It will copy the data from a source to target and load it. So there are different activities which we'll be talking about in depth while talking about Azure Data Factory. I wanted to discuss this point. So some random activities are copy activities, okay, for each activity, then lookup activity, store procedure activity, then we have web activity. These are different activities which we'll be using going forward to design the pipeline, to orchestrate it, and to use it. The other component is basically trigger. It's not a component as such, but I can still write about it. Triggers are used to schedule the pipelines. Again, there are different types of triggers, which we'll discuss again in the next classes. I think in the module 4. But yeah, triggers are used to schedule my pipelines. Once a trigger is scheduled, my pipeline will be activated or my pipeline will start running on those particular scheduled times. So I think I have covered most of the part as a basic of Azure Data Factory. We'll cover the remaining things in the next lecture, which will be module 4. But yeah, I have covered all the topics of module 3, and we will deep dive into Azure Data Factory, how to create a pipeline and all those part in the next module. I hope you have liked these classes. If any questions, please reach out to us and you can ask the questions directly.
I hope everything is clear. If you have enjoyed watching this video, please do like and subscribe to Scalar's YouTube channel. If you want to watch similar content in future, do not forget to subscribe to Scalar YouTube channel. Thank you for watching this video. We'll see you again.